Good morning. And thank you for joining me today on this presentation, how we are using HexAGON EAM at CERN to maintain the most complex research facility of the world. Okay, the first question, anybody knows what CERN is? Okay, I have 3 hands. Okay, let's jump in it and explain what is really. Okay, CERN is the world's largest research center for particle physics. Our name is originally a French abbreviation for the Conseil européen pour la recherche nucléaire, but we are only concentrating on the physics part, what's inside the nucleus of the different elementary particles and how our universe is built up. We are providing tools for the researchers to do their investigation and really find the answer, what is the origin of our universe and how we get there and how it's working. And to facilitate that, we are building enormous particle accelerators. Currently, we have 23 member states, roughly 10,000 people who is on our different sites, collaborators from 80 countries with an overall budget of roughly 1.5 billion. Our largest machine is the LHC, the Large Hadron Collider, which is located outside Geneva, Switzerland, and in France at the same time. You see the zigzag red line, that's the border between the 2 countries. So we are having a very exceptional scientific installation, which is physically in 2 different countries. So it's additional challenges related to that. The accelerator itself, it roughly contains 100 million components, and it's located in a 27-kilometer long tunnel, about 100 meters below the surface. And here we are accelerating particles, more precisely protons, to the 99.99999% of the speed of light, roughly 11,000 times per second, to provide large enough energy for collisions for the physicists. When I'm saying these things, these numbers, it's very hard to imagine. Let's put into perspective. If I'm putting our installation on the map of Paris, you can see that our accelerator is roughly corresponding to the periphery around Paris. And we are maintaining this infrastructure between 2 countries. Of course, we have the tunnel itself, which is roughly like the size of a metro tunnel, which is housing the machine and thousands of superconducting magnets with an operating temperature of 1.8 Kelvin. We are having 4 large experiments where particles are colliding, and we are speaking about structures with a height of roughly 8 stories, with a top weight of around 12,500 tons, which is roughly twice the Eiffel Tower. We have the corresponding computing facilities to crunch the data, what we are collecting, and all the supporting things around it, because we need cooling to have this operating temperature. We are using electricity up to 200 megawatt punctually, which is corresponding to 1 average nuclear block in France. And we are having a direct connection to both the French and the Swiss electrical network. And we are running 2 sites with about 600 buildings on it to house all the functions and providing office space and lab space and workshops for the 10,000 people who is on site. So it means that we have assets in all flavors, sizes, and complexity. We have the tunnels, we have cooling, ventilation, electricity, we have computing facilities, we have our safety services, like we have a fire brigade, we have all the buildings, we have stores, rental facilities, we are operating even the largest hotel complex of the Geneva region, and all these things are having 1 single data depository, which is the HexAGON EAM. Just to have few numbers about how large is the installation, we are roughly having 3 million equipment, which is having roughly 350,000 work orders every year. We have keeping over 100,000 different spare part references, and we have 3,600 users in a very specific environment where we have a software which is not modified. So a solution which is flexible enough to house all our needs. In these days, everybody is speaking about digital, going digital, and we are also going in this direction. And we absolutely know that if we don't have the proper data, we don't have the proper data capture, the proper data quality, the formats, the links between them, and manage over time, we cannot provide that experience which is a minimum in the 21st century. Also, our installations are having very, very long life cycles. Imagine that we still have elements and buildings which are from 1954 still in use after many refurbishment and many updates and maintenance. And we also have software which is evolved during the times. If you just see these few years, in the last 40 years, how software changed, and it can change also in the future, but the important thing that we have the data which is making the bridge between the generations of the builders and the generations of the maintainers. And when we are having such complex, long life cycles, we have to also concentrate on it. What really capture, how to capture, and what is really the information that we'll use in the future. And these things are going through the whole life cycle of the equipment, from the specification, through the design, the manufacturing, the installation, the operation, and not to forgotten, the decommissioning and the management of the waste during the dismantlement. To manage the digital thread and have all these things, you have different tools at the different stages of the process. We are having a document management system. We have CAD designs and product lifecycle management during the design phase. We have manufacturing where already 3D scans and eventually stuff from EAM is coming into the game. And after the installation and the commissioning, we have to really use these things and combine with the real data what we are having from the different equipment, using SCADA systems, having IoT devices to simplify and make it more efficient, the operation of this whole system. If you are thinking on some hardware which is coming from the HEXAGON technology tool set, we are using different kind of scanners and microscopes to collect data which are helping to have the comparison between how things have been designed and how they are built and installed to really have the connection. When I'm putting all these things together, we have a platform which is centered around HexaGon EAM and providing the necessary connections to all the different fields which are important for the asset management. We are having support for the design and configuration management. We already collecting data on upcoming equipments from the manufacturing stage. Of course, we are managing the whole maintenance and operation. And also, we are managing the waste. And which is quite interesting in this context, we are also managing potentially radioactive waste also. And all these things are together in the EAM from HexaGon. And this is connected, used a web service hub to having the connection to the SCADA systems, other databases, ERP, and all other systems around us, which are relying on the EAM data as the single source of the truth. If we are looking into the different steps to have some examples, for the manufacturing and testing, it's very important when a new thing which will be built for us, either built at CERN or built at the manufacturer, from the point when the manufacturing starting will be identified, labeled, and data will start to connect to these elements. Mainly, this data is recorded on mobile devices or on tablets. Sometimes we have manufacturers who are still a bit old-fashioned in the 21st century and providing Excel files. But no problem, we can have the data, capture the data, and keep the data. And it's very important to use functionalities from the EAM to simplify the work, like we are having equipment configuration, templates with structures, design data. We have standard work orders which are prescribing what are the steps necessary during the manufacturing phase. We are having checklists to validate every single step which is requiring something information. And of course, we are also recording non-conformities using EAM. When we are on the field, we can very proudly say all maintenance managed and documented through EAM. If it's done by CERN own employees or it's done by subcontractors, in the same fashion. And we are having contracts where we are prescribing that if somebody is, as a subcontractor, making anything on any equipment, we are not paying until it's properly registered in our EAM. Of course, to be able to do this efficiently, we need mobile devices, and we have a bring your own device policy. So the contractors are using their own devices to enter data into our EAM system. And we have lots of functionalities from the PM schedules to the routes, managing projects, running millions of checklist lines every year, managing warranties, having integration with ArcGIS, so we know exactly where our equipment physically around the 27-kilometer ring. And we are managing also the contracts and the logbook entries. At the maintenance, we've seen an explosion in the last few years of the usage of the checklist. In the past, everybody was running around with papers, folders, they tried to note something, somebody else tried to enter information, and usually the result was just a mess. Since we have the electronic checklist in place, everybody is using that, which is helping to have up-to-date information, having structured information, because instead of having a command, they are probably putting in a single value or checking a single text field. And with that, during the maintenance, we have over 1 million checklist items completed. And to be able to do that, we have our own extension, which is called the EAM Lite. It's an open source extension to HexAGON EAM, connecting through our open source web service hub. And this allows to have a reactive web application available for the contractors. So everybody needs a single web browser. If it's coming with a phone, coming with a tablet, coming with a computer, nothing to be installed, nothing to be deployed, which could be a headache with contractors, you just open a web link. And from there, you can do everything which is necessary to be able to execute your work, have the documentation, the registration, which will lead to your payment. And the maintenance, we are using a lot of data coming lively from the equipment. We are having integration with SCADA systems like Siemens, and we are having a lot of IoT devices. These are usually connected with LTE or LoRa towards our systems. And for example, with such approach, we can significantly reduce the maintenance cost of equipment which are not used continuously. Imagine that, for example, we are having cranes accessing the experimental halls, which are only operating very limited time during the year, because the rest of the time, the physics is the priority and we don't need the cranes. And if you are following the normal manufacturer prescriptions, at every 3 months, every 6 months, you have to do something. But if you can prove that how many times the crane is starting and how many hours it operates, with the proper exact data from the IoT devices, it can significantly cut your cost. Also, we are going towards more smart solution, like we have integration with ABB for registering information on motors, especially on usage and vibrations. We are capturing this data, it's ending up in the ABB cloud, and we have the possibility with the SCADA bridge from the EAM to recuperate this data and use this for the maintenance planning. When we are having maintenance, we need spare parts. And we are having lots of spare parts, roughly with 150,000 transactions in a year. We can have storerooms which are a single cupboard, and we have facilities which are over 15,000 square meter covered space. And both ends of the spectrum is very, very nicely managed with HexAGON EAM. We have the integration with the GIS because in a football field-sized storage facility, you should know where you are finding that thing what you really need. And we are having a simplified interface which is available on kiosks or available on mobile phones, and doing in the same fashion how you are doing your self-service checkout at the supermarket. But here, instead of scanning your Fidelity card, you are scanning your employee ID, and then you are scanning the codes of the things that you need. And at the same moment, you are linking it to an equipment or linking it to a work order. So you have, from the moment onwards when you touch the equipment that you take as spare parts, you can connect it into the digital thread. I also mentioned that we are having potentially radioactive material. And for that, we created a solution which is solely based on HexAGON EAM. Basically, we have a combination of equipment and a combination of work orders to represent the different functionalities. And we are very proud that we managed to have an agreement with the authorities of Switzerland and France to accept that what we are having in EAM about the radioactive material, that's the truth, and we don't need any other further software solution, documentation, anything on it to satisfy their needs. So eventually this could be also the solution for the very end of the life. And of course we have the operational measurement, analysis, declaration of waste, and also the waste processing when we are separating the different materials, compacting them, and preparing them for the further transport. And in this case, we have roughly 1,500 users who are using the declaration that I have something that I can take out, and probably it could be that it's radioactive. So deposit in a buffer zone and ask for the registration, the measurements, and the declaration before I can take it. And we have this function available in dedicated stations, or even a technician can initiate it from their mobile phone that this equipment will need things. When we are going towards the digital world, with the EAM, we have the potential to combine the information on the equipment, the information that we had from the CAD design, and the measurements of the real-life environment. And we can visualize in 3D how our equipment is working, and this can help the management of the maintenance processes, can provide the base data for virtual realities or augmented reality on the side. And it can allow combining these things to help really preparing of interventions. Let's see a very simple example of navigating when we will have a look on the tunnel, and we will look for a collimator, an element which can eventually activate it, where the data from the equipment is really coming from EAM. We have the models from the engineering design. And let's see how the information can be used, like when we are running our mannequin through, and the mannequin's color will change correspondingly how much is the potential dose that he can get in that specific point based on the measurement data what we are having in EAM. And then maybe we'd like to have a look where this dose rate is coming, and then we have our 3D panoramas where we can really look what is the equipment eventually causing the problem. And then, based on that information, we can define that we will need an intervention, and we have to have an intervention area around this point because it's causing an issue. We can just mark the perimeter, and we know that there we will need, for example, a vacuum cleaner to clean up some problems. And then right away we can also create the intervention request for that position in the tunnel. And then the technicians can use that information, and even afterwards they can look it up, okay, how far is from that point in the tunnel where we can find the first exit where eventually the material can be moved out. And then you see that we are navigating on the map on the top corner, and also we are navigating the real model in the irregularity. And when we are having these possibilities together, it's really important to use our data efficiently to really connect the 3D, the models, and the reality together. Because then we can have the possibility when these are providing additional help at every stage. And as you can see how it's compared, for example, the photo of a certain section of the tunnel, the corresponding digital model, which is having all the additional information together in the same spot. So to conclude, we are very, very happy to have HexAGON EAM, because it's proven itself that this very highly configurable platform can provide the base of all the integrations what we need around our processes. We are happy to extend and expand the EAM through other functionalities. And as part of our integrated engineering platform, it really provides the link between the design and how things are built together. And we are absolutely sure that HexAGON solutions will help us and other users in the future to have similarly successful solutions for the real-life applications. Thank you. And afterwards, if you like, of course, I can answer the questions. Si vous avez des questions après, je suis aussi prêt pour répondre en français pour vous. Merci.